Have you ever stopped to think about how you can send an email from your laptop, say in London, and have it show up perfectly formatted on a phone in Tokyo? I mean, it really feels like magic, doesn't it? But it's not. It's all about architecture. Today, we're going to unpack the invisible blueprint that makes our entire digital world work, the OSI model. So let's start with the big question. How do all these billions of devices, your iPhone, my Android, that Windows PC at work, even your smart fridge, all made by completely different companies, somehow manage to speak the exact same digital language? You know, it's a genuine miracle of modern engineering that we just take for granted every single day. Because, let's be real, it wasn't always this seamless. Back in the early days of networking, it was just chaos. You had a world where a computer from one company literally could not talk to a computer from another. It was a digital Tower of Babel, and this problem was seriously holding back progress. To fix that chaos, the world needed a common language. It needed a universal blueprint for communication. And that idea is exactly what we're diving into in our first section. And here it is, the Open Systems Interconnection Model, or what everyone just calls the OSI model. Now, think of this thing as the ultimate rulebook. It doesn't actually build the network itself. Instead, it gives everyone this standardized 7-layer framework that tells them how to design their hardware and software so it can play nice with everyone else's. So to make this all click, let's use a little metaphor. I want you to imagine the OSI model as a giant, 7-story digital post office. Every single piece of data you send has to travel through each and every floor. And believe me, every floor has a very specific job to do to make sure that data gets where it's going. And that brings us right to the core of this whole thing. We're about to take a journey through that post office, floor by floor, so you can see exactly how this incredible process works. All right, here they are, our 7 floors or layers. We're going to start at the very top with layer 7, the application layer. That's the one closest to you, the user. And then we're going to work our way all the way down to layer 1, the physical layer, which is the actual hardware sending signals through the air or down a wire. Now, to make this even easier to digest, we can actually group these 7 layers into 2 big chunks. You've got the upper layers, that's 7, 6, and 5, which are all about preparing your message. And then you have the lower layers, 4 down to 1, which are all about the nitty-gritty of actually getting that message from point A to point B. So let's start at the top floor, layer 7, the application layer. This is basically the customer counter where you write your email or open your web browser. Then at layer 6, the presentation layer, your message goes to the translation department. This floor makes sure your data is in the right format and might even encrypt it for security. And finally, layer 5, the session layer, acts like a dialogue manager. It opens up a communication line and keeps it going until you're done talking. Okay, so once the message is all prepped and ready, it gets handed down to the lower floors. This is the delivery network, the part that figures out how to actually get it across the world. Next up is layer 4, the transport layer. You can think of this as the certified mail department. Its whole job is to make sure your data gets there reliably and in the right order. It's handling all the error checking and flow control, kind of like making sure the person on the other end isn't getting a flood of mail they can't handle. Down at layer 3, the network layer, your data gets its global address. This is where the packet gets stamped with the destination IP address. You know, that unique address for the recipient out there on the internet. And then this layer figures out the absolute best route for that package to take. This is the heart and soul of routing. Okay, now we're at layer 2, the data link layer. This is like the local mail sorter in our post office. It couldn't care less about the final destination city. It only cares about getting the mail to the very next stop on the line. It handles data transfer between devices that are directly connected, like from your computer to your Wi-Fi router. And at last, we hit the ground floor. Layer 1, the physical layer. These are the mail trucks, the roads, the airplanes, the whole shebang. This layer takes all that neatly packaged data and turns it into raw bits. We're talking electrical signals, pulses of light, or radio waves. And then physically sends it out over a wire, a fiber optic cable, or just through the air. So as you can see, data doesn't just magically jump from your screen to another. It takes a really specific round trip through all of these layers. Let's quickly trace that journey. When you send data, a process called encapsulation happens. Your data starts at the top, right? Layer 7. As it travels down each floor of our post office, each layer adds its own header. Think of it as another wrapper, like an address label or a tracking number. So the data packet actually gets bigger and bigger as it goes down, until by the time it hits the bottom, it's fully packaged and ready for its big journey. And on the other end, well, the exact opposite happens. It's a process called decapsulation. The data arrives at the ground floor, layer 1, and starts traveling up the 7 floors. At each level, the corresponding layer reads and rips off its own header, unwrapping its part of the package. The packet gets smaller and smaller until finally, at layer 7, your original data is revealed to the application. It's a really beautiful, perfect symmetry. Okay, this is a really cool model conceptually, I get it, but you're probably wondering, why does this thing still matter today? Well, this quote right here just nails it. In the real world, the internet we use every day is actually built on a simpler 4-layer model called TCP/IP. But, and this is a big but, the OSI model is still the absolute best tool for learning how networks really work and for troubleshooting when they don't. It's the textbook that teaches all the fundamental principles. Its legacy is just massive. It's the universal standard for teaching this stuff. It's a critical framework for diagnosing problems. I mean, when your internet goes out, I guarantee you an IT pro is mentally walking through these 7 layers to figure out where the problem is. It gives everyone a common language for these super complex systems and provides the foundation we need to design the networks of tomorrow. Which leaves us with one final thought. If the OSI model is the super detailed 7-story architectural blueprint, what's the name of the actual building we all live and work in every single day? Well, that is a story for another time.